Good morning, guys. I'm sorry I'm not in school again today. Couple of quick announcements. The essays that were to be due on Monday, this past Monday, the last time we had class, I think there was some confusion. So I'm going to allow you to turn them in on time, no later than next class on Friday, and I'll consider them on time. If you emailed them to me, then I have them. I'll print them out. They are turned in. You're all good. The other thing is quizzes. I'm not giving you a quiz today because I'm not there. I don't think that's fair. But I do want to give you a quiz on 5-1, 5-2, and today's 5-3. You'll have a quiz on Friday. I have not made it up yet, but I'm guessing anywhere between 5 and 10 questions based on those three sections, and that will definitely be on Friday. So if you have any questions, email me. Make sure your questions are answered before Friday then. So today is 5-3 angle bisectors. So this goes back to chapter 1, just as a quick review, an angle bisector. So here's an angle. I'm going to make this to be an angle bisector. I know this is an angle bisector because these two markings tell me that it is. So it divides this big angle into two angles that are equal. So remember, a segment bisector, it divides a segment into two equal pieces. So in this case, this piece, these two pieces are the same because this bisected this segment. In this case, this bigger angle is being bisected by that ray. So we have two littler angles that are the same measurement. So using that idea for today, the angle bisector theorem, it says if a point is on the angle bisector, then it is equidistant to the sides of the angles. So looking at my first picture here, so here's the point that's on the angle bisector. I know it's the angle bisector because I see these markings that show that I have two equal angles. So if it's on the angle bisector, then it is equidistant to the sides. So as a side note for that, so let me draw you a new picture here. Here's my angle bisector. I know it's an angle bisector because of my markings. Here's my point that I know is on the angle bisector. It says it is equidistant to the sides. So these dotted lines are the equidistance. I know it doesn't look like it because it's a sketch, but these dotted lines are the same distance. Remember, we've talked about distance before, and distance always has to be perpendicular. So these lines must be perpendicular. Think about if you're going from one point to another, you're never going to make a line that's not perpendicular. That's going to be your shortest distance. So from here to somewhere on this line is this perpendicular line, and it has to be perpendicular. So these two dotted lines are the same because that dot is on the angle bisector. So angle bisector theorem, if a point is on the angle bisector, then it is equidistant to the sides of the angle. The converse of the angle bisector theorem says exactly the opposite. If a point is on the interior of the angle, remember here's, for this angle, this is the interior. So if there is a dot somewhere, or a point somewhere on the inside of that angle, and it's equidistant to the sides of the angle, then we know it's on the angle bisector. And again, it is important to note that these lines have to be perpendicular. Let's look at a couple of examples. So the first example here says find the measurement of angle JKL, which is this bigger angle. If you look at what's given to you, M is perpendicular. There's two lines where M to L and M to J are perpendicular, which means that is the distance from that angle bisector to the sides of the angle. That perpendicular has to be there. We also know that there's equidistant. Therefore, we know that this is an angle bisector. Because it's an angle bisector, if this angle is 43, this one also has to be 43, which means the entire angle has to be 86 degrees. Another example We want to know if BD bisects ABC. So we want to know if this ray bisects this bigger angle. We need to check for two things. We need to see that D is, we have two lines connecting D to the sides of the angle, and we also need to know that that line is perpendicular and congruent. So if you look at the first one, we can see that AD and DC are perpendicular, and that's great. But we don't know the distance from A to D and D to C. So for that reason, we cannot say that BD bisects ABC. So because we're missing the distance here and the distance here. For this one, we know that the distance is the same from A to D and D to C, but we're missing the idea that it's perpendicular. So just as an extreme example, here's kind of a recreation of this one. It could, you know, the drawing may or may not be accurate. It might look something like this. There is no way those two lines are perpendicular. Just because they're congruent, that's great, but they have to also be perpendicular. So that one's a no. This one is okay because we can see that D could be on the perpendicular bisector. To verify that, I can see that these two lines, AD and DC, are perpendicular to the outside of the angle, and they're also congruent. If you can see these little markings, these little tip marks mean that AD and DC are the same length. Just because we don't know the exact length, that doesn't matter. We just need to know that they're congruent. For this example, it says find X. Well, looking at the picture, I can see that this is the angle bisector because of these little markings. This is on the angle bisector. We do have perpendicular lines because it's marked, which means these two segments are the same. So I set up my equation, setting those equal to each other because I know they're congruent, and I found that X is 8. Okay, this is our construction for today, and I do have a video of me making the construction. So let's talk about what this all means. Again, I want you guys to watch that construction of me doing this. We will do constructions in class when I'm back in class. For right now, I just want you to be exposed to it and be aware of it. But you will have hands-on experience. I'll make sure that we do that in class sometime very soon. Okay. So in my construction, I want you to see what's going on in this picture. So right here, it's hard to do this with one hand. Okay, that's an angle bisector. You can see that I have two equal angles here. This one is also an angle bisector. I can see that here. And this line is an angle bisector. My meeting point of my angle bisector is called the in-center. So I can take any triangle, draw 3 angle bisectors, and the meeting point of those 3 lines is called the in-center. The distance from the in-center to each side is congruent. So let me just stop there for just a second and make sure that this makes sense. Yesterday, Monday, we had a triangle and we did perpendicular bisectors. And this is just a sketch. And we said that this center was the circumcenter. Circumcenter is the meeting point of perpendicular bisectors, and it is equidistant to the vertices. So that distance, and this distance are the same. So this is circumcenter. That was last lesson. This lesson, the in-center is the meeting point of all your angle bisectors. So this is called the in-center. The in-center is equidistant to each side. And we know that that distance has to be perpendicular. So this is in center. And this is where it's really important that you see the difference between the two. Meeting point of perpendicular bisectors equal distant to each vertex, that's circumcenter. In center is the meeting point of angle bisectors equal distant to each side, and that's called the in center. So when you have directions that say that this point is the in center, you know that these are perpendicular bisectors. You also know that these three lines going from the center, the in center to the sides, are congruent. I believe I have 2 more examples for you. Okay, example 4 says point P is the in center. So as soon as they tell me that, I know that this is an angle bisector, this is an angle bisector, this is an angle bisector. That's not important for this problem, but what is important is because this is an angle, because those lines are angle bisectors, this is the in center, which means JP, JL, and PN are all congruent. They're asking us to find JP. Well, look at what's going on in this picture. To find JP, I don't have anything going on over there that's going to be helpful. But if I can find PN or LP, then I'm good. So I'm going to use this triangle right here. Because if I can find PN, then I know JP. So what I did here, I used that triangle. And I do have a right triangle, and I'm going to use the Pythagorean Theorem, which should be somewhat familiar to you. In the right triangle, your C side is directly across from your 90-degree angle. Remember, this is your Pythagorean Theorem. C squared equals A squared plus B squared. Your C side is directly across from your 90-degree angle. The other two are your sides, or your legs, I should say. So when I plug that into the Pythagorean Theorem, I find that PN is 7. So again, when you plug it into the Pythagorean Theorem, if you're not comfortable with this, or if you're not familiar or remember this, you always square things first, get rid of those exponents. And then I subtracted 576 from both sides. So I got 49 equals PN squared, or X squared if you want to look at it that way. And when you square root as your last step, because to get rid of that 2, you have to square root to get that to get rid of it. So PN is 7. One more example. It says find the value of X that makes N the in center of the triangle. So they want this to be forced to be the in center. So in order for that to happen, these 3 must be congruent, which means I need to figure out what that X is. So I'm using this triangle here. It's hard to write with my phone in my hand. So if I can figure out, remember, NM and LN are the same. So that has to be 4X. I'm using this triangle to figure that out. So hopefully you can follow me here. This triangle is this one here. So what I did is use the Pythagorean Theorem again, but be careful with this. You know, A squared plus B squared equals C squared. 52 is my C. Be careful with this first one. That entire length is 4X. So when I square it, 4 squared is 16. X squared, of course, is X squared. I got rid of those parentheses and I squared everything. Subtracted 2,304. Then I divided by 16, and of course my last step is to square root. So I found that X is 5. This one was a little bit trickier, and I believe there's a couple problems like that on your homework. Take your time with it. I think it's just more of a thinking thing, but I think you guys will be fine with those kinds of problems. You can see the homework down here if you want to pause it and jot your homework down. I also have it on the notes as a PDF on Schoology. So remember, next time on Friday, you will have a quiz on 5.1, 5.2, and 5.3, roughly 10 questions. Please email me any kind of questions that you have. I will do my best to help you from home. Like I said, I'll do my best to help you. So thank you for being cooperative, guys, and working on your own today. Like I said, I'll do anything I can to try to help you.